Adding rational expressions. Okay, to add any rational expressions, even if they're just regular fractions, you got to get common denominators. So that's what we're going to work on first, getting our common denominators. So our numerators are 5 and 7. Our denominators are 3x to the 4th power times x plus 3 to the 7th power. Over here we have 2x squared, and we have x plus 3, and then to the 6th power. All right, now let's work on getting common denominators. Now, we have a 3 and a 2. We have to use what's common in their multiplications, in their multiplication tables, and the least of the commons. So what 3 and 2 have common in their multiplication tables is 6. They have also 12 and others, but 6 is the smallest or least. So we're going to use 6 in both of these. So 6 here, 6 here. Now, we have an x to the 4th and x to the 2nd. When it comes to powers, we use the larger one, so we're going to use the x to the 4th. Here and here. And here, for this binomial, this is x plus 3 to the 7th, x plus 3 to the 6th. The larger exponential would be to the 7th, so we're going to use that in both. So x plus 3 to the 7th here, and then x plus 3 to the 7th there. All right, and then put the 5 and the 7 there. Now, what we're going to do is now find out what's missing. So here we have a 3, and here we have a 6. The difference between multiplying 3 and multiplying 6 is that a 2 has been included. So the 6 is actually a 3 and a 2. So a 2 has been included. So since there's an extra 2 multiplying in the denominator, we'll put an extra 2 multiplying in the numerator. Okay, you have an x to the 4th here, x to the 4th there. Nothing has been added. We have a x plus 3 to the 7th there, and x plus 3 to the 7th there. Nothing else has been added there. Now let's go here. Here we have a 2 here and a 6 there. What has been included from the 2 to get to a 6? Well, the 6 is actually a 2 and a 3. So what has been included is a 3 to get to the 6. So since there's a new 3 in the denominator, we'll put a new 3 in the numerator. So times 3 there. Now we have an x to the 4th here, and we have a x to the 2nd here and x to the 4th there. So there's actually 2 extra x's. So let's put 2 extra x's in the numerator. And finally, we have 6 x plus 3's here, but 7 x plus 3's there. So there's a 1 extra x plus 3 in the denominator. So we're going to put 1 extra x plus 3 in the numerator. Okay, now let's put all this together. Our new denominator is 6 x to the 4th, x plus 3 to the 7th. The 5 and 2, 5 times 2, that makes a 10, so we'll put a 10 here. And then plus, and now we have multiplication to do. We're going to multiply the 7, 3, x squared times the x here. If you multiply 7, 3, x squared times x, you're going to get a 21 x to the 3rd power. And now we're going to multiply the 7, the 3, and the x squared times the 3. So we multiply 7, 3, x squared times 3. I think that's going to be a 63. So plus 63 x to the 2nd power. And that's it. And we're done. All right, next. Our numerators are 4 and 1. And this is going to be a 5x squared. And my binomial is going to be an x minus 7 to the 3rd power. So we got 3 of those. Next we have a 6x to the 3rd power. All right, and an x minus 7, and that's to the second power. All right, now it's time to get common denominators. Let's put the numerators up there real quick, 4 and 1. Okay, so we have a 5 and a 6. So what's common with 5 and 6? The 6 and 5 timetables have a lot of numbers in common. They have 30, they have 60 in common, also 90, a lot of numbers. But the lowest number they have in common in both their multiplication tables would be 30. So we're going to put 30 in both places because that's the least common multiple. Next, we have an x squared and the x to the third power. Now when it comes to powers, we use the higher power for the least common multiple. So this will be x to the third here and x to the third here. Next, we have an x minus 7 to the third and x minus 7 to the second. Well, the higher power will be the x minus 7 to the third, so we'll put that in both places. X minus 7 to the third power, and here x minus 7 to the third power. I don't know if that looks like a 3. Hope it does. Okay, now let's see the differences. The differences, multiple differences between a 5 and a 30. Well, the 5 had to be multiplied by 6, so there's an extra 6 here. Instead of a 5, there's a new 6 here, so let's put a new 6 here. Okay, and we have an x squared there on an x to the third power, so there's one extra x here, so let's put one extra x in the numerator. And here we have 3 of these x minus 7s, and here we have 3 of the x minus 7s, so there's nothing extra there. So let's go here. So we have a 6 here, but a 30 here. So what's additional here, multiplication-wise? There's an additional 5 in the denominator. So there's the 6, but there's also a 5. So we're going to include a 5 here. And we have 3 x's here and 3 x's here, so nothing's in addition. X minus 7s, we have 2 here, but we have 3 here. So there's one additional x minus 7 in the denominator. So let's put an additional x minus 7 here, one of those there. Okay, so now we can get our common denominator of 30 x to the third power, x minus 3 to the third power. Okay, here, 4 times 6 times x, that's going to be 24x, or x to the first power, same thing, understood 1 here, plus. All right, we're going to multiply the 1, the 5 times the x. So 1 times 5 times the x will give us 5x. And the 1 times the 5 times the negative 7 will give us negative 35. Now, in this instance, we have 2 common terms. We have a 24x, or like term, should I say, and a 5x. These can be combined to become a 29x. So 29x and the negative 35, and they'll all be over this denominator. I don't have room, so just imagine this as the denominator. Okay, next one. Our numerators are 4 and 3. And this denominator is going to be 3x to the 5th power. And the bottom term is going to be x minus 2 to the second power. Okay, x minus 2 second power. This will be 6x to the third power. This is x minus 2 to the third power. All right, now let's see if we can get the common denominator here. All right, so our numbers are 3 and 6. When you look, 3 and 6, their timetables have lots in common. They have 6 in common. They both of these have 12 in common, 18, 24, lots of things in common. But the least number they have in common in their multiples would be 6. So we'll put a 6 here, a 6 there. Here we have x to the 5th, x to the 3rd. So we're going to use the higher power, which would be x to the 5th. So we'll put that in both places. X to the 5th here, x to the 5th there. And here we have the binomial x minus 2 to the second, x minus 2 to the third power. So it's more here. So we're going to put this one in both places. So x minus 2 to the third power, and then x minus 2 to the third power. Okay. Hope that looks like a 3 here. Maybe that'll help. All right, so we still got 4 and 3 there. All right, so let's find out what's new. We have a 3 here and a 6 here. What's new to the denominator, going from a 3 to a 6, is there's an additional times 2 here. So let's put additional 2 here. From x to the 5th to x to the 5th, there's nothing additional. But from x minus 2, we have 2 of them here, to x minus 2 to the third power, we have 3 of them. There's one extra x minus 2 in the denominator than there was in the denominator there. So let's put an extra x minus 2, one of them, in the numerator. Now here we have a 6. This is a 6, so that's common. That's the same. But here we have x to the third, here x to the 5th. So there's 2 additional x's here in the denominator. So let's put 2 additional x's in the numerator. Here we have x minus 2. There's 3 of them. Here we have x minus 2. There's 3 of them. So there's nothing addition there. So we're going to go ahead and write our common denominator as 6. X to the 5th power times x minus 2 all to the third power. So we're going to multiply these two and times x. So 4 times 2 times x will be 8x. Next, 4 times 2 times negative 2 will be negative 16. And here we have a 3x squared, so we're going to put plus 3x squared. And we are done with this problem.